Hello and welcome to TidyX episode 167. TidyX is a screencast where we go through and explain how our code works. My name's Ellis Hughes.
And my name's Patrick Ward. Thanks for checking in at TidyX with us. As always, be sure to hit that like and subscribe button on the bottom. Hit us up with questions, comments on the YouTube channel. As always, if you enjoy the work and you want to support the show, we do have a Patreon page. We're really appreciative of anything that you'd like to give. That all said, we're going to jump into episode 167. I think this is our
Third episode.
third episode on base R plots. So again, most of the work that we've done has been in ggplot2, but the past three episodes we decided, hey, let's introduce everybody to a different way of plotting. Sometimes it's good to understand the basic nuts and bolts components of things, and also sometimes you're in situations where you don't always have access to maybe the Tidyverse package or the ggplot package or the package that you like, and you're working a job where you can't just readily load those things. Base R can get a lot of work done and do a lot of the heavy lifting for you. So today, episode 167, we're talking about plotting distribution. So when we have our data, how do we plot and evaluate visually the spread of the data?
Exactly. So as always, we need to start with the data set that we're going to be using. So we're going to be using the Lahman packages we've been using the last two episodes, and we're going to be using the batting data set. Of course, we're going to be filtering then to keep all cases using base R here. So the nomenclature is square brace, rows, comma, columns that we want to be keeping, and square brace. And so here we're saying any case where the year ID is greater than 2010 and less than 2020, so between the years 2010 and 2020, and the at-bats is greater or equal to 100, so they bat at least 100, been up to bat at least 100 times. We're going to then keep league ID, year ID, the player ID, team ID, runs, and hits, so R and H. And we're going to assign that to DAT, and we can take a quick peek at DAT. Hey, look at that, so many rows. But we're then also going to call drop levels, and this is going to be removing all of the factor levels that exist. Again, as we've talked about, this removes any levels that, because this is a factor, it may have levels that exist in the overall batting data set that no longer exist in this cut down version of the data set. So we don't want to leave that in there. So we'll call a quick head on that. Hey, look at that. We've got league ID, year ID, player ID, team ID, runs, and hits, as we expected. And all the hits and runs and whatnot are all included there. So for the first step we're going to want to do is we're going to want to do an aggregate. So this is going to be essentially a combination of a summarize and a group by, if you're used to the Tidyverse world. Again, knowing this formula here, so this is a formula structure. So this is some dependent variable based on some independent variables. So we're going to say calculate hits by year ID, team ID, and league ID on the DAT data set. And when you have multiple values for that, or when you're calculating this new H, or take the mean of H. So this is basically summarizing H by mean, by year ID, team ID, and league, right? So we run that, and we get this new data set here where we have so much information about year, which team, which league, and then the average number of hits of that year. So now we've got league year. Now we can try to create our first type of plot. Patrick, do you want to show us how to use this new box plot function?
Yeah, so let's look at box plots. So box plots we've done a whole bunch of, and it's simply the box plot function. If you want a single variable box plot, you can pass it just an X variable. However, if you want a box plot that is conditional on some level of information on a certain level, so this is the X version, right? So there we have the box plot, and all we're simply doing is plotting the distribution of the average hits. Year on the x-axis there is misleading because Ellis didn't comment out the X
Here,
label.
I can be better. Here we go.
Yeah, there we go.
Look at that.
So that's basic box plot. Oftentimes when we're building a box plot, we might care about the distribution between some level of groups or factor levels. So in this case, we can build a box plot that shows the distribution of hits conditional on the year or the season. So if we run this, we apply it as a formula function and we get something that looks like this. And this is great. And some people prefer horizontal box plots to vertical box plots. So all the code is the same. The only thing we're adding there is that simple argument horizontal equals true. And then I've also added, which we've talked about a lot over the last 2 episodes, this AB line where I want a vertical bar at 100 hits. So I'm just kind of like setting that as my threshold of interest. And so we're just going to strike a red vertical bar that's going to be rather thick. And line type 2 means that it's going to be dashed. And so there it is.
Hey, look
Great.
at that. Doesn't that look pretty nice? And the nice thing about this too is a number of the base R plotting tools have consistent argument names. And so kind of jumping between the different ones, different functions, it's pretty easy to mean. Oh, that's the title, X lab and Y lab are the Y and X labels. And so it's pretty easy to move between a couple different of those plot types,
That's
at
right.
least for the labeling, due to
Yeah.
the fact that it's consistent arguments, which is a nice thing to do.
Yeah. So that's a little bit of an intro into plotting some distribution. Sometimes we have data that are factors or characters or levels, and we want to count how many there are, and we want to visualize that. And a bar plot is a nice way to visualize the number of counts. Ellis, you want to talk us through this part here?
Sure thing. So what we're going to do is we're going to call the table function, which is essentially going to return a number of counts we have for any factor level. So what we're going to be doing here is we're going to take dat. We're going to filter it to keep all cases where hits is greater than 100, which means that we're going to be keeping all the records where at least the player had at least one. No, how many teams had 100
Well,
hit players? Yeah.
teams, yeah.
So on average, had 100 hits, and we're going to pull team ID. So then this is going to just give us a wonderfully long vector with a ton of different levels here. And that's kind of tough to read. And then you'd have to count, okay, how many times did Baltimore, how many times did Milwaukee, Miami, Tampa Bay show up? But the nice thing about table is it's going to summarize that into Arizona appeared 55 times, Atlanta appeared 57 times. And so that's a table, but that's also not a great way, or that's how you call table, but that's not a great way to visualize this information as we're trying to do in this series here. So what we can do then is actually throw this into a bar plot. And so we're going to take that same tabling function there and we're going to throw this at bar plot, and it created a type of plot. It's a little bit difficult to see because it's trying to plot every single one of those x-axes there, and because we're zoomed in a little bit, there we go. If I spread this all the way, so for Arizona it shows 55, Atlanta, so it kind of shows us the same information from the table, but now as bar plots or bar yeah.
Mhm.
So, but then that's not the only thing that we might want to do. See how we can't see all those x-axes there? If we set the LAS argument to bar plot to 2, that flips it. And all of a sudden, we don't have to spread our viewer out all the way there to make sure that we can see the x-axis labels there, because they're not as wide, therefore it's going to show all of them. You can set LAS to 3, and that then changes the y-axis as well. There might be situations where that is valuable for you if you're trying to have a more compact plot in the x direction, I guess, to do that. So that's, and no, it doesn't go up to 4. That is not a graphical parameter you can set. So let's undo that. Let's set this back to 2 here. But this is kind of not super helpful because this is showing it by alphabetical team, which may be how you want to view it if you are used to viewing, if it makes sense to display data in an alphabetical order, or in a way where the categorical variables need to be shown in a certain order. This makes sense. But that's not the only way you might want to do it. Sometimes you want to show it actually by the order of the hits. So who were the best hitters and who were the worst hitters team wise, or had the most number of seasons that had no, most number of
Which,
hitters.
which team over this time period had the highest number of 100 hit play, greater than 100 hit players,
Yes.
right? So
So,
which teams had the highest number of big hit players, right?
exactly. So now we're going to call sort on this table, and that's now going to change the order of the table to enter it in like this, where uh, the Oriole, no, FLO,
Florida?
Florida, Florida has the least number of 100 hitters over this time period, and then Texas had the most. So then we can throw this into our bar plot. Same settings. Now we have our main argument, so our title being number of 100 plus hitters per team. The /n means new line from 2010 to 2019. The Y label is number of hitters, and X label, we don't want any labels because that's not valuable information. And there you can see, if I move us over to the left here, it's ordered now from least hits to most hits. And we could probably flip that around here, going off. Oh, no, we can't do that in, what if we call,
Yeah, I think is it
I think it's
yeah,
Rev.
I
Going
think
off
so.
script here. There we go. Yeah. So this is you call rev, which stands for reverse. So it just flips the order of your vector. And now we have most hits to least hits, which might be the way you want to display it as well. So now you know both ways. So that's a bar plot, but there's also histograms. Patrick, do you want to take us through histograms?
Yeah, so histograms are another way of evaluating or providing a visual of the distribution of the data. So the basic histogram takes the hist function. It takes only one variable because it's obviously you're looking at the distribution of a single variable. So in this case, it's going to be runs. And we give it our X and our Y axis label. So, and that's fine. And there's our histogram. And that's really cool. You can see on the y-axis that these are counts. So 0 and then just under 200 in that bin, and then just up to 800 in the kind of, 10 to 20 bin, and, just under 800 in the 20 to 30 bin, et cetera, all the way down to the 140 bin, which has like one. But sometimes it's useful to make this something more like a frequency. So maybe you want to look at these bins relative to each other as like a percentage. And so the way to do that is we just take our entire hist function there and we just dump it into the plot function. The main label and the X and Y axis are all correct. I'm just going to color the bars light gray because plot is going to, by default, make them white with a black lines around them. So I just want them to stay with the gray color. And all I do here is I give this the FREQ equals false, or sorry, uh, yeah,
Yeah.
frequency equals false, and this is going to put it into a proportion. So now we can see that we have percentages. We have a density on the y-axis. Okay. And that brings us to our next plot, which is the density plot, which is basically going to be, instead of bins, like a histogram, a line. And so the way we do this is we say plot the density of runs. I'm going to keep the x-axis label the same and the title the same. I'm going to make the line colored green and a pretty heavy width. So line width of, or line weight of 5.
And remember, because we called plot, this is now a new canvas. So it's not writing over the
That's right.
previous plot that we had. It is now drawing a new plot. So anytime you call plot, it's a new canvas.
And notice that the y-axis is a density again. And so if we have our histogram as a density and our density plot as a density, we can now overwrite, just as Ellis talked about, we can write over that histogram. So that's the original density histogram. Now, instead of calling plot again, which would erase this, we're going to call lines, and it's going to paste it on top of what we see. And now we have both the density plot and the histogram viewable for the end user. And sometimes that's a nicer way of kind of looking at the data.
Helping understand so you don't have to do a ton of bins in your histogram in order to
Yep.
try to understand the spread or the actual distribution, because I think typically you don't want to be using like the default bin width that comes with the histogram function here. You want to be setting your own.
Yeah, you can make them small. I mean, you can make smaller bins if you want. Um, I can't remember in base R which it was, but I don't
Eh,
think it's brings. I thought it was bins, but
I
maybe it
think
is.
that's the ggplot way.
Oh,
Uh,
you might be right. Yeah.
but I know you can't update hist here. Let's actually go on a quick side quest. A vector, a function to compute a single number giving the number of cells. So breaks. So let's say breaks equals 20. So now you've increased the number of bins that exist. So now we have 20 bins
It's
for our
gonna
plot
be,
here, which then more closely represents our
yeah. So
distribution
if we
here.
did like
But this may be
100
more
bins or something.
more information than your stakeholder needs to know for making a
Yeah.
decision. So then you can reduce this. Go, oh, we only want 5 categories. So let's do 5. So that kind of shows that. But you can then understand the actual YLM, how it actually is spread out to overlay these two to get like a basic idea and then a more detailed understanding of it and how the two relate to one another.
Yeah.
But that's kind of falling back, and I think this is nice to see how things kind of stack up on one another. How a lot of these functions kind of can work together to increase the amount of information that exists in your plot, um, and using things like the lines function, which could be which is what we learned last week, in combination with this new technique that we learned about plotting the density here. So that's got a nice S3 method for or lines has an S3 method for a density data set when it gets added to it.
Mm.
And so that brings up a whole world of methods and whatnot, which leave a comment down below if you'd like to learn a lot more about methods. We've touched on them a little bit when we've talked about object classes before, but if you'd like for us to go into that in more detail, love to hear that from you all. So with that, I think that's episode 167, how you can use base R to make some nice density and distribution type plots using just base R. As always, my name is Ellis Hughes, and you can find me on various social media sites at Ellis_Hughes.
My name is Patrick Ward. You can find me on X at OSPPatrick at tidy_explained is where the screencast lives on X. But best way to get in touch with us, YouTube channel, like, subscribe, drop the comments down below. Let us know if there's something else you want to see or if you want to see us expand upon. As always, we have a Patreon page. If you enjoy the work that we're doing, you feel like it's helped you, we're super grateful for anything that you'd like to contribute to help support the show. That said, this is 167 episode of TidyX.
Thank you all so much, and keep on exploring your world.